I'll do a rundown of that later when we get to his section on it. But hopefully you're coming with questions and things that you want to learn or understand, or tips that might be able to help you find opportunities. Today's objective is helping you find those opportunities. So we're going to start off with a quick chat, general discussion about how you can go about finding those opportunities in your facility. Then we're going to start looking at specific common opportunities in the food and beverage sector and things you can be looking for that are specific to your facilities. And lastly, we've got a good chunk of time for questions and answers. So this is a great opportunity to take advantage of Bruce's knowledge and expertise. So hopefully you've brought some questions about opportunities at your own facilities to get the most out of today's session. We do encourage interactivity in these sessions. So we will be having Menti polls, questions, but also at any time, if you have questions, you can use the Q&A panel or the chat that we will be monitoring, or also feel free to raise your hand and be ready to come off mute, turn on your video to share your experiences or your questions. We do have a participant workbook that summarizes some of the key information we're going to be talking about, but also has some spots for you to take notes or participate in particular ways as we go through. Will's going to drop that into the chat, a link to that. So if you could open that from the link and download it to your own computer. So it is a read-only copy. So please open that link, download a copy of that workbook so that you can follow along and fill it out as we go. So going back to the question we had at the beginning of this presentation, for the late joiners, there's instructions at the top of the screen to go to menti.com and the code to join. We will be using that throughout today's presentation. In terms of what kind of energy saving opportunities you're pursuing, it sounds like some are still looking for those low-hanging fruits. Some have kind of exhausted those maybe and are focusing on more challenging, more integrated projects. But it seems like there's a lot of people that are in that sort of middle ground. There are still some of those low-hanging fruits that you're pursuing, but you're moving into these more challenging projects. What do you do next? So I think today's going to be a great opportunity both at, for those that are earlier on, getting some tips to get started and find some of those quick wins, but also what does it look like when you start looking for those more integrated solutions? So that's really great. Moving on to our next question. I want to hear a little bit about what do you do to find energy saving opportunities, energy efficiency opportunities in your facilities. So you can go back to Menti if you have that open in your browser or phone already. If not, the instructions are at the top of the screen and the link is in the chat. But I'd like to hear what do you do to find those opportunities? So you might be doing energy hunts with your staff, also known as Kaizen or energy treasure hunts. Do you review equipment energy use data, vendor recommendations, employee suggestions, doing audits? What do you do? All right, so we're seeing some of those pop up. Looks like a lot of people undertake those energy audits, reviewing equipment data, and energy data as part of that, vendor recommendations. All right, so we got a good mix coming on there. Oh, and energy audit still out of first place. So it's interesting to see a range of different strategies. I do notice that someone mentioned other, either coming off mute or typing in the chat. Would whoever answered other care to share?
Oh, that was actually me.
Oh.
So we've already done our own energy audits and whatnot. We're just on the last mile, so we have to kind of specialize.
Oh, okay, a little bit more like equipment or specific expertise coming in on certain areas.
Yeah. So next week we're installing a heat pump on our thing, just because that's our remaining consumption. We're down to 3 tons, and so we're going to deal with that.
All right. So it looks like there's a range of strategies that people are using. In practice, we tend to lump these into, or you can lump these into 3 categories. These aren't official, but you can look at data analysis, baseline models, interval data, benchmarking. You can do site investigations, like we mentioned, like the audits, those energy hunts, talking to the operators, because those are the people who know the equipment the best and what's going on, or employee strategies, which is sort of getting them more involved, engaged, supporting energy efficiency efforts through training, suggestion box, or looking at how opportunities can be built into their plans. One thing about these is you do want to have a mix. And I think in the last question that we had, we saw that there's a lot of different strategies happening. And you kind of want to employ all of these, because if you're not, there's possible gaps. So if you're not doing that data analysis, then you're using untested assumptions. You think things are being done a certain way, that may not be what's actually happening out in the facility. If you're not doing those site investigations, you may not have a really good understanding of the processes or what is going on. And if you're not bringing those employee strategies, you may be lacking some really important insights into the work that's already being done or how they do things. And also facing challenges in terms of a lack of adoption and the stickiness of solutions because they haven't been involved in the process. So in our workbook that we have, if for those late joiners, a link to that will be dropped in the chat so you can open and download your own copy. But I'd like you to go to page 2, and there's a list of some of the strategies that we mentioned. And you can check off or circle the ones that you've already been doing. And also make notes if anything came up just in the discussion or some of those examples of areas that you'd like to start doing or maybe formalize a little bit or do a little bit more. And right now, I'd be curious of if there's any of those strategies to identify opportunities, and would anyone want to share some of those that they want to start doing, or that maybe they're kind of doing it, but want to do it a little bit better? All right, and it looks like we're having some errors or challenges getting that workbook down. So we'll work on getting another link to that if that's not working for some people. Max.
I can share some of the strategies that we use. If you look at the previous slide where a little bit of each, we ran a cohort system with Australia where we ran through several modules to make sure that the employee engagement was taking place. And then within that, we had a module on our EMIS and energy data where we looked at the monitoring, targeting, and reporting. So we're looking at that data analysis and gathering the data. And then we also we've got some reference documents that we use for typical savings measures for different systems within the plant. And we got that tool and we constantly kind of update it. So as different sites implement projects, we share those with other sites. So that's a useful way to find opportunities. It's almost like a series of questions that the site maintenance folks can ask themselves about a system. So for the boiler, there might be 4 or 5 different things. The key one being, have they done a steam trap survey? And do they have boiler controls? Do they have an economizer in place? Just those questions, and then they can answer yes or no. And if they answer no, then they then set about the next steps for that particular opportunity. Yeah,
and I love that because it's giving a better understanding of, hey, what is in place, what do those processes look like, but it's engaging people in that process, which I think is really important as part of this whole process. The next thing to look at, and this is going to be on page 3 of that workbook. Thankfully, now that people can download that, that's great. And we're going to start looking at different types of energy waste. And as we go through some of these types and some of these examples, what I want you to do is think about where these might be occurring in your facilities. So, and there is a spot on the worksheet to write down any ideas. So if we go through these and you're like, oh, I think that might be occurring in this system or in this area of my facility, you have an opportunity to write that down. These are the 9 types. We're not going to go to these in super detail, but as I mentioned, we'll do a brief description of them to help you think of it. Now, one note on this is the purpose of this is not to have these strict definitions and be like, oh, wait, is this waste one of, like, is it a leak or is it suboptimal efficiency? That's not really the goal here. The goal here is just to provide some illustrations of what waste can look like to help you think of where this may be occurring and to recognize waste when it is occurring. So this can be really useful in terms of training staff and thinking what they're looking for. So Max, I see your hand there.
Yeah, if you just want to go back to the previous slide, I just want to make an interesting comment on these types of waste. So about a year ago, I attended a webinar put on by Tetra Pak and their technology division, and they had their global energy management sort of specialist come on, and the question was posed, like, where do they see the biggest opportunity? And it was specifically to dairy processing, but I imagine it's probably the case with other food processing. And I was expecting them to say something like boilers or the packaging equipment or like air compressors, like something like that, or heat pumps. But they actually said it was around scheduling and the utilization of equipment and the overall equipment effectiveness. So that bottom center underutilization is, I'm happy to see that. And it was very surprising to hear that. But I guess it kind of makes sense, because every time you're running a piece of equipment, they're not producing anything, you're just wasting all that energy.
Yeah, and I think what we'll do here, and these will lead into some of the examples Bruce has to share as well, but we'll start looking at like what these look like. So the unnecessary running or idling sounds pretty self-explanatory. Is equipment running when it doesn't need to be? Now, the trick with this one is that sometimes thinking about what needs to be means isn't totally obvious. So the example here, like ovens need to warm up before production starts, but do they need to warm up 2 hours before production begins? For suboptimal efficiency, that refers to any equipment system that isn't operating as efficiently as it could. So, could it be improved by upgrading the equipment, changing sequencing, or other operating parameters? So thinking about where that might be happening in your facility. The last one on here is misapplication. So this means using a wasteful or very energy intensive piece of equipment or process when a more efficient option is available. Use an example of compressed air to clean off clothing is a particularly egregious and not particularly safe example that we do see sometimes. But also, food and beverage, how many times have you seen someone use a high volume hose to push some product across the floor into a drain instead of using, a broom to sweep it up on there? Leaks is another pretty obvious one to imagine, even if sometimes they aren't the easiest to spot. They can be hidden, and this could include, leaks in water, refrigerants, compressed air, heating and cooling, both leaks through ducts, but also leaks out of, say, uninsulated pipes or other systems as well. Malfunctions. This might seem like an easy one to spot. It's like, hey, if the equipment isn't working, it's pretty obvious. But a lot of times this could be things like actuators that people think or assume are working and are being controlled, but they never actually check. So you could be looking at your BAS or your control system, and it's like, oh yeah, we're controlling this damper based on this input, and then you go out there and realize that the connection to the damper is broken. So the system says it's being controlled, it's really not. And that can be a bit hidden if you're not paying attention to things. Underutilization, as Max mentioned, this is a really big one in food and beverage. So, are you running ovens at half capacity, production lines, other processes, whether it's batch or continuous? Is it oversized? Are you not sort of optimizing that use? Friction loss. This is something I think some of the first things that come to mind in here are moving parts like motors or conveyors. A good tip is if it's noisy, it's not being efficient. But this can also include things like buildup within pipes that increase like how much pressure is needed to pump things around your facility, or on heat transfer surfaces that limit the efficiency of that heat transfer from one area to another. And the other one that is I think often a big one in food and beverage is traditional lean waste. So if anyone's gone through lean or Six Sigma, there's things like lost product, excess processing, overproduction, unnecessary motion or transportation, waiting time. While these are usually around the product that you're producing, all that stuff has embedded energy as part of it. So energy plays a big role in those as well. And I think we're going to be seeing some of those. So hopefully you've been thinking where these may be looking like in your facility. And the last one that I'm going to look at is system imbalance. And for this one, I'm going to ask you to share where you see this occurring in your facility. So please be ready to share in the chat or come off mute and let us know. But system imbalance, this occurs when the work being done by a system doesn't match what's really needed for it. So this could include, equipment like chillers or pumps that are running full speed, full capacity, regardless of how much demand there actually is for it. It could be temperature settings that are too high or too low relative to what's needed, or it could be equipment like pumps, motors, chillers that are oversized for the work that they're doing. One last thing before I ask people to share where they think these may be occurring, where they've seen this kind of thing occurring in their facilities, is one thing to keep in mind is there might be a good reason for this imbalance. Like you might be running these systems over capacity because the risks of under delivering what's needed are too high, and you're okay with that additional cost or energy waste because you don't want it to mess up or cause some issues. Maybe the equipment used to be right size, but things in your facility moved around or changed, and now it's oversized for what's needed. Or there might be some conditions upstream or downstream that are necessitating this equipment to over deliver or causing those issues. Now, it's important to remember that these good reasons doesn't make it not waste. It just means finding an efficient solution could be a bit more challenging. And I'm looking forward to Bruce talking a little bit more about that. Before we move on, does anyone want to share examples of where they suspect system imbalance might be occurring in their facilities or where they've seen it occurring? Who would like to share that with us? We're actually going to go to Menti on that. So we'll be moving over there, and you can use Menti going back to your browser or phone to enter in examples of where that may be occurring or where you've seen it occurring. Right. We'll give a second just for people typing in there. Oversized air compressors. That's one that we do see it a lot, and this is one where demand may change in the facility. Maybe you had really oversized air compressors, or maybe you got sold one because they're like, hey, you don't want to be undersized on your air compressor, but it might not turn down efficiently on there. You may not have controls that allow it to turn down to meet the actual need. I'm not sure why those answers aren't showing up there. I'll bring this over here so we can see some of those as they pop up. So that's really common. Also, we see that a lot with pumps as well, where you're moving a fluid, you're needing something, stuff got moved around, or the process has changed. Maybe you improved efficiency somewhere else that you didn't need as much water or whatever being pumped there, but now that pump is oversized and you're having to maybe inefficiently turn it down with dampers or valves, or even with a VFD. If using heat pump sizing, that's a good one. I think that's one that's coming up a lot. There's a challenge that a lot of facing added production, oversized compressors, inefficient cooking equipment. All right, steam production. That's an interesting one as well, particularly as your demands in the facility change. All right, so this is a good thing to think about. And as well, you can use the page on the worksheet and the examples there to go back to your facility and start thinking about where these may be occurring. Max, did you have something to add?
Yeah, it's just when you look at like an efficiency curve, your system might have been designed with the equipment sized at the most efficient point on the efficiency curve to meet like a production level. But then as production expands, you're now having to push the equipment right to the limits, and then the efficiency sort of drops off. And I suspect we see that in some cases, or production tails off, and you're turning something down, but it's not designed with a very efficient turn down ratio.
Mm-hmm. And we've seen that for like also in like pump and fan systems a lot, where like you said, it's designed for a particular system curve, and then things change, and you're not operating within that, and not only wasting energy, but you may be having challenges like production related challenges as part of that as well. All right, still in Menti there. One more question that we're going to move on from talking about like how you identify those and what those wastes look like to what are your three biggest energy users. So these are the pieces of equipment in your facility that consume the most energy, and we often refer to these as significant energy users, or SEUs. All right, so we've got some in here: refrigeration, freezing, pumps, fans, compressed air. All right, the ovens, cleaning systems. All right. So these are some of the big areas that you're looking at in food and beverage, common areas that show up. And we're not going to get into a lot of managing SEUs in this presentation, but I do want to touch on them briefly because you want to make sure that they're operating efficiently. So on page 4 of your workbook, we do have a little bit of a summary in terms of managing SEUs. So you do want to make sure that this equipment, these big energy users, are operating efficiently. We have a brief checklist on page 4 that you can go through to see what are you doing, some steps you can take to ensure those large energy users are operating efficiently. For those of you that are familiar with ISO 50001, managing those SEUs and having plans in place to manage them is a big part of that. If you're interested in learning more on that, we're not going to get into it today, but there's some links to the ISO 50001 Ready dashboard that provides some guidance on doing that. And also coming up, Save on Energy program will be adding, an online course around managing significant energy users that's going to be available later this year on their training page. If you're not familiar with that training page, we'll drop a link to that into the chat right now. Just a show of hands, so there's a little raise hand button on here. How many people are doing some or all of those on that checklist on managing your significant energy users? Like that you have identified them, you've identified those variables or people that are influencing it, you're sub-metering it, you have KPIs that you're monitoring and doing corrective action on that. All right, we see a few hands coming up there. Okay. Oh yeah, they're starting to pop up there now. One thing, if you aren't doing this actively, or if you think there are opportunities to improve upon that, I would recommend looking into those processes on managing significant energy users. All right, so now we're getting into the part of the presentation where I'm going to hand it over to Bruce to talk about some of his experience in saving opportunities in the food and beverage sector. Bruce is for those of you who aren't already familiar with Bruce, he's the president of EnviroStewards, excuse me, an engineering firm, over 20 years experience, who've helped hundreds of organizations achieve environmental goals while improving bottom line. By taking a holistic approach, focuses on preventing those problems that we kind of talked about that lead to waste at their source. And EnviroStewards doesn't just help others become more sustainable, they also walk the walk, applying their core principles to reduce their own footprint, achieve B Corp certification, and addressing inequality through projects in developing countries. As Bruce, I'm going to hand it over to him. As he's going through the presentation on page 5, feel free to take notes as you go through on that. And again, following that, we are going to have a good amount of time for Q&A. So think about what questions you may have, either about anything that's covered in the presentation or questions from within your own facility about opportunities that you're thinking about or may want to pursue. All right, so I'm going to hand it over to Bruce now.
Wonderful. Yeah. Thank you, Jay. And so nice to see so many people are interested in this topic. And Yes, would love to have some great Q&A at the end. And so if I didn't touch on something, get in the chat early. But basically today I want to go through kind of how we find practical, affordable ways to further improve efficiency. And I'll go through kind of the approach that we use, but I'll illustrate it with case studies from various food and beverage manufacturers and other manufacturers. And we'll have the Q&A at the end. The payoff for your facility would be higher margin, smaller footprints, and brand stewardship. So a lot of people don't necessarily consider brand stewardship in the equation of their payback analysis, but you can potentially increase your top line sales by improving your position with your customers through this type of work. And so, if you want to go to the next slide, please, Jay. So here's our own due diligence. So we're a tenant. We're in a 100-year-old furniture manufacturing building, and anytime we need more, we just subdivide a little bit more and renovate it and use it, and we pay like it's warehouse space. So it's good for us, good for the landlord. And so that's some of the things we do. So you see that plant wall there. So what we do is we suck our office air through that wall. That amount of plants can take out the air from 10 employees. And so we have about 18 now, but we kind of keep up, and with remote and whatnot. So basically what it's done is it's reduced our air intake by 97%, because we don't have to take outside air to get rid of the carbon dioxide, because we're making oxygen out of it with the plants. It's also taking VOCs out. Our air quality is actually better than the conventional office directly below us that uses the 10% makeup air model. On the right, that's our rainwater harvesting. So basically, right now we're getting snow melt. We get rainwater, and that's cut our water. We put that water in the plant wall, which is better for the plants and whatnot. So these are, it's kind of maybe unique to us, although we are doing a factory right now where they're going to put one of these in their lobby, right? Because it's a nice environment also. So that kind of thing. I don't know if we have a slide of the roof also. Is that on the next slide or not? Maybe I should talk about it. No, okay. So our roof, we have what's called a blue roof. So every time it rains, we just leave the water on the roof, literally. So we have 2 inches of water on our roof when it rains. In the wintertime, we let it down because of freezing concerns, but the rest of the time we just use the snow load. So we didn't have to do any structural change. But that cut our air conditioning 43%, cut our water in half because we got free storage up there, cut our heating in half because we got better insulation, and cut our stormwater discharge by 100%. So we don't discharge during a storm anymore. Even though the first floor below us is Toyota Oshoku, they used to get flooded out in the past because we had 100-year-old drains, right? We're getting more intense storms. Now we don't even use the storm drain anymore, that kind of thing. So anyway, if it's of interest, feel free to reach out to me afterwards. There's videos on it on our YouTube channel also. We've said that we're going to cut 80% per employee, and so far we've cut 88% per employee through efficiency measures. And we're doing a heat pump next week, actually, that's going to get rid of 75% of our remaining footprint. So it's going to get us up to high 90s on conservation, then we offset the rest. Is kind of what we do for our own journey. So next slide. But our bigger impact is for other people, right? So for every ton we're using ourselves, we avoid at least 40,000 tons at our customers' facilities on their footprints. So it's not on our footprint, but that's what we call kind of the work of our hands or service. And in this world is called scope 4, is the effect of the product or service that you're offering on the environment. And so in this case, here's an example. So Maple Leaf Foods, it's the world's first large food company to be carbon neutral. And it's not 2030, not 2050. They got there in 2019. And it didn't cost them money. They publicly report that they've saved $17 million so far, and they're carbon neutral. Well, how do you do that? So we went to 35 factories. We found 1,300 things. So I don't know, what's that, 30 each between those 35 factories, of which they've implemented half so far. Still implementing more, but even that half has been enough to get them all the way to zero, because you can fund the offsets with the savings and have money left over. And you just keep chipping away at what you're doing and buy less offsets in future years, kind of thing. And the deep conservation gives you the credibility. If you just do the whole thing with offsets, then it's not credible to anybody. But if you do the conservation first. So anyway, that's just an example of somebody who's ahead of the curve on the decarbonization. Next slide. So here's how we get there. And this is, today, that yellow box, that's where we're going to be focusing on mostly, but I want to show you where it fits in that journey. So let's say, whatever you want to call it, net zero, decarbonization, whatever, you're on a journey. And so let's say you go to a mall. the first thing you want to see, you see the map, you are here. You know, you want to go to the food court, you have to know where you are and where the food court is so you can plan a path to get there. Same thing for your factory. Where are we now? So what's your scope 1 and 2 is your operation. So the fuel you're buying, the electricity you're buying, that's all part of your scope 1 and 2 operations footprint. Scope 3 is your supply chain, your packaging, your ingredients, which is most of your footprint. So then on the conserve, and you put your metering on at the beginning there, and you leave the metering till the end. So at the beginning, that metering is using to establish your baselines. And we do it at the facility level, but also at the unit operation level, because that's where you can actually change things. So then midway through, that same meter is kind of monitoring the progress, letting you know when you lose that progress because somebody threw a valve or turned something off. And then at the end, it's proving that you got there, and it's quantifying the savings. So that metering ties the journey together, but in the middle, you've got the conserve step, which we're going to be talking about today. And then, so on the conserve, you know, there's quick win stuff, you know, under 1 year, you know, in food, there's under 1 month even stuff, right? And then the strategic stuff that's going to need some investment, but it's going to make a big difference. And then the bullet below that is the supply chain. So you're going to look at, you know, if you want to get to zero for everything, then you're going to look at, you know, your biggest ingredients, what their footprint, what you do about it. So that's a tougher nut to crack. But the operations is where the real financial savings is. And then step C is how do you credibly replace what's remaining? So say in the case of Unilever, what they do is we're cutting the thermal energy about half, then we're electrifying what's left, and then we're going to replace that amount of electricity. Is kind of their way to credibly, affordably get there, right? So the conservation pays for the savings that you need for the rest of it. So when you get to the replace, you just want something that you feel comfortable defending. So in our case, we did solar panels on a roof in an orphanage in South Sudan, right? And so we get twice as much daylight there, so we get twice as much energy from every panel. So we feel comfortable defending what we're doing for the last mile, right? And then we buy offsets also. But next slide.
Actually, Bruce, there's a couple of questions. One is SDB. What's that referring to?
F&B?
SDB rich projects.
Oh, sorry. Yeah. It's a typo. That's what it is. It's supposed to be SDG, Sustainable Development Goals. So say like we have a water project in South Sudan, Uganda, where we teach people to build water purifiers because then you don't have to deforest to boil the water, right? So you save that way. And so the Sustainable Development Goals, there's 17 of them, right? So in addition to carbon, climate action, it also provides employment, education, equity, because you don't have to carry the water, you know, all these other co-benefits. So sustainable development. So when you pick a project, you don't want to just do carbon, because with the same investment, you can do carbon, employment, you know, all these other co-benefits. Yeah. Sorry about that.
And there was another question going back to the other one in terms of what were some of those obvious changes that Maple Leaf Foods made. Like you said, there were a lot of these opportunities, 30 per facility. Do you have a sense on some of the common ones or the ones that kept coming up?
No, that's a great question. So they have a master spreadsheet with those 1,300 things in them. And so each year you can come up with, okay, what are we going to do this year? What effects is it going to have? What's the business case? What do we got to spend? You know, so you've got, you know, all your plants on the same basis, right? And so, and there's some nice cross fertilization. If a plant in one province says, hey, we can't do that, you say, well, why don't you talk to your guys in this province because they're already doing it, right? And so you can get this kind of, so I would say each facility was unique. So each facility, those 30 recommendations were unique to that facility. But some common stuff would be heat recovery, heat reuse, has a big impact on your footprint, sanitation, the guns you use, you know, that kind of stuff, how you heat that water. Most plants are heating ice cold water with brute force, whereas we can preheat it with something else. Compressed air is common. Boiler, you may or may not want to invest in getting the stack. You know, the nice thing in food and beverage, you have more sources of heat than places to put it. So it's a matchmaking game of what's the least expensive local place to get this heat and reuse it, and what's quantified and stuff like that. So food and beverage is nice because you use a lot of energy in a very small footprint, and you can kind of do this matchmaking game. And so some of those I'll maybe come to when I'm doing the specific examples, but those would be a lot of the common areas, I guess. Yeah.
Okay, great.
Yeah, thanks. And so typical things in a food and beverage, you might find lighting, lighting, most people are actually ahead of the curve on lighting now, but if you haven't gone to LED lighting, it's a good thing to do. If you did you actually put any occupancy sensors on it? You might have rows in the warehouse and nobody actually goes down, right? Yes, it's an efficient light, but does it even need to be on, right? So lighting, that kind of stuff. HVAC, HVAC is very expensive, and I think I'll have a slide on that later on, but basically, if you're exhausting air, it doesn't matter what kind of windows you have. It doesn't matter what kind of insulation. You're forcing your heat right out of the building. Or if you're temperature controlled, you're forcing your air conditioning right out of the building, right? And so you want to have a good reason why you're exhausting. You want to have a good reason why you're exhausting at that rate. And can we get that energy back out of what we're exhausting? So HVAC kind of thing, there's a lot of good stuff. Dehumidification is a very expensive process also. You want to look at that. Compressed air. She is mentioning kind of the ability to turn it down. So variable speed drives let you turn them down to 30%. Interestingly, we did a winery in California, and when we logged their air compressor, it was beautiful, top of the line variable speed compressor. You can't buy a better one, but it's shutting itself off several times a minute. Pretty soon it's going to kill itself. So they're using less than the minimum output of the VFD. So less than 30%. And so we just bought one third the size, and this one never even comes on anymore. And so right sizing, and sequencing if you have more than one, if you've been in any of the compressed air ones, if you have the normal compressors, the load unload, when it's loaded, it makes air, which is great. When it's unloaded, it makes zero air, but uses 60% of the energy. So if you have an odometer on your air compressor that shows the loaded and unloaded, all the unloaded time is opportunity for you. And that you could, reap some other way kind of thing, right? So anyway, compressed air is big. Refrigeration, it's very expensive. It's very necessary. But what do you do with that heat afterwards? Do you just pay to get rid of that heat, or do you reuse it? Do you vary your controls based on the weather or not? Do you take advantage? Hey, it's winter right now, right? These kinds of things. CIP is very common also because you use a lot of hot water, right? And do you have fire hoses going, or do you have nozzles, or can you substitute pressure for it? So once you get into the details, that kind of thing. Yep. Next slide. So here's a good example, right? So on the refrigeration side. So very, very often, people will come. The person who visits your factory is the person who sells something. And they'll do a free assessment for you because they sell something. And whatever they're selling actually is better than what you're doing now. But is it the best thing to do? Right? And they may or may not know, because to find out, you need to know the whole system, not just that thing they're selling. So in the case of direct fired hot water, it's great. Basically that thing on the left, you take compressed air and you put it right into the water you're trying to heat up, and 97% of the energy goes into the water. Right? And that's great compared to your 60% efficient system, or 80, whatever you've got now. However, if you're a food and beverage, you probably got the thing on the right also, where you're condensing your refrigerant, where you're paying to get rid of the energy from your refrigerant. What if we preheat with that? Then we take the load off that tower, so we save electricity, right? We save water because we save chemicals, and we save natural gas because it's like you've cut your journey by 2/3 that you need to do with your gas. So your old crappy heating system, you're like 150% efficient versus 97 for this brand new thing. So it's a nice slide because it illustrates the difference between optimizing a process versus optimizing the system, I think. And so once you've got your logging, you can do the math on these kinds of trade-offs. Next slide. Yeah, so here's kind of the approach that we use, and there's a green skills course that we are providing through EMC if anybody wants it. It covers water, electricity, gas, upcycling, whatnot, kind of thing. Yeah. But here's our approach. So the Enviro Stewards approach: who, what, why, where, when, how. So who are your energy? So basically, the very first thing we do is we have a kickoff meeting with the key stakeholders at that particular facility. So it's interesting, we do work in South Sudan, Africa, which is a completely different culture than Canada. If I want to get anything done, I have to navigate that culture. Similarly, those 35 Maple Leaf factories, every single one has a different culture. If I want to get anything done, I have to navigate that culture at that facility. Best way to do that is to involve the stakeholders at the beginning. So, we need an hour and a half of their time so they know what we're doing, why, how, right? Then we go away, and 2/3 of the way we get that same team together. And at that point, we've got our water balances, energy balance, we've got our root cause, we've got our opportunities we're going to recommend. And we go through it with that team of their stakeholders, which might include sanitation, engineering, maintenance, boiler operators, procurement, right? If we can get agreement, then we do the installed capital cost of those ideas. If we don't, we throw out the idea. So when they get the report, their team of stakeholders already agreed to every idea in that report before we wrote the report. That way you get this high implementation rate because everybody's already on board. So the hard part isn't the technical, it's bringing everybody on board. We say engineering change, and the hard part is the change, right? The easy part is the engineering. And so who is very important. So you want to think about who's going to be affected by the types of things you're changing, then what. So that's where you put on these meters. So that's a clamp on water meter you see there, but we have clamp on electrical loggers and temperature loggers, whatnot. Minute by minute, where's it all going? That gives you your Pareto, your largest contributors, like Jay was mentioning, where a 10% improvement in this is better than wiping out these 3 tiny ones altogether. So you're focusing your attention where you do them. Then why? So we do a root cause analysis. So this is what a lot of people don't do. What job is the energy solving for you? What job is the water solving for you? And you go all the way back and you get different answers, right? Rather than marginal gains, right? Can we solve that same job differently, right? And so you go all the way back with this root cause, and then you get this buy-in, and then you do the, when it should be implemented, has to do with the payback analysis, that kind of thing. And then it's going to save you nothing till it's implemented. So how do we get this thing implemented? What's needed? Somebody's got to write a capital request. Somebody's got to get 3 quotes. Somebody's got to do the P&ID. Whatever is needed to get it done, commissioned, and operational, and then using your meters to prove you got there and you're staying there. So that's kind of the approach we like to use. Next slide. Okay, so here's an example of the exhaust that I was mentioning before. So you see that red circle, that's an exhaust fan at a factory. In this particular case, it's not food, but it's a good illustration. So they're doing auto sector. So they get the paint solvent from Ford, Chrysler, Toyota, and they distill it and sell it back to them. So you got this still bottom tank there. So when we measured that fan, there's a lot of energy going out that wall. So why do we have the fan? Well, it's not safe to breathe in here. So I used a meter. There was a very high concentration of volatile compounds coming from that still bottom tank into the air, and then they're blowing it out the wall. So the solution was, let's seal that tank, vent it through the existing condenser you see at the top there, condense it as solvent, sell the solvent. Now the solvent's not in the air. Now you don't need the wall fan. So it's weird, but you save more energy by doing a toxic study than you can save by doing an energy study. And this is kind of that holistic thing where, if you did electricity, you get a better motor. If you did thermal, you could get a heat exchanger, get some of that back. But do we even need the thing, right? So next slide. Oh, sorry, on that slide is interesting. In the field of systems design, they say that if you study any system, you can only learn 60% of that system. If you want to know the other 40%, you have to know all the other systems it's interacting with, right? And so that's why we advocate for these kind of holistic kind of assessments. So next study. So root cause analysis. So here, here's an example of this why, and then we'll put you to work, I think, on the next slide. So start thinking about kind of whys and root cause. So here's a plant we did, and they're making lard, for baking pie crust and stuff like that. And so when we did our walkthrough, one leads to the other also. So I'm doing my walkthrough. The first thing I noticed is there's 22 liters of boiling water going down the drain all day long. Why is there boiling water going down the drain? When I traced it back, it's coming from a tank that gets the reject from a centrifuge. So they were centrifuging this lard, and every minute it would dump out mostly lard with a tiny bit of solids in it into this tank. And they were putting the boiling water in there so that lard didn't freeze in their sewers and flood the factory. Okay. What if we reprocess that lard? If you reprocess the lard, you get to sell the lard. You don't need the water. You don't have to boil the water. You don't need the chemicals. You don't have to float it out in your treatment plant, and you don't have to pay somebody to haul it away as a dilute sludge. So basically, the further upstream you can solve a problem, the better it is for you. The further downstream, the better it is for me, actually. To build them an effluent treatment system, I would make a lot of money to destroy that food. But by preventing it, it's very small for the consultant, but very good for everybody else. Next slide. Oh, sorry, there's another example before we get into putting you guys to work. But anyway, so here's another example. So this is Southbrook Winery. If you've been on wine tastings down in Niagara-on-the-Lake region, Southbrook, they're already great. They're LEED Gold certified. They're organic, biodynamic. They're top of their game. They had a energy audit done under an LDC contract, I guess, and that found, hey, you're doing great. The next 5% savings is 20-year payback. So they said, okay, well, we're going to do solar panels instead because that's a 10-year payback. After that, but before they installed them, they hired us. And we said, actually, it's not 5% saving, it's 40% savings. And it's not 20-year payback, it's 4-month payback. How do you find 40% in the same facility? So here's an example. Yeah, you can leave it there, that's fine. So one of the, to give you an idea of kind of more of the details, right? So that's their wine cellar. So their wine cellar had a very big ventilation system. So yeah, we got to keep the wine 17 degrees plus or minus half a degree. Okay, does the wine have to be that or the air? The wine. Okay, so we put a jug of water in their wine cellar with a temperature probe in it, another one in the air beside it. Turn the system down 70%. The thermocouple in the water never moved. We just left it 70% down. And so when you turn it down with the fan curves, you save almost all the electricity because of the fan curves, but you also save 70% of the gas and whatnot. So that's kind of one thing. Next slide, maybe. Here's their wine tasting building. So that's the CO2, carbon dioxide, right? So the blue there, that's kind of where you actually need to maintain it under that. So basically, most of the time, they're over ventilating. So what if you had a CO2 control? You'd only have to do it, a tiny amount of the day there, right? And if you did that in their case, it would save them that much electricity, gas, money, right? By controlling that. So again, that comes from logging, right? Next slide. Here's their electrical switchgear room. We said, well, has anybody got a key? Well, I think so-and-so's got a key. So we go in there and there's warm air on one cheek and there's cold air on one cheek. It's not very sexy, but why don't we just change the set points so that the air conditioner doesn't fight with the heater all day long, every day in a room that nobody ever goes in, right? And so on the right there, that's their heating loop, and the left, that's their air conditioner fighting against it. And so the challenge is a conventional audit is, what is an energy audit? That first one actually is an energy audit, the 5% 20-year payback. It's just a useless one. But you can make that one without even going to that winery. New LED lights, new chillers, right? To find this stuff, you actually have to go to the winery, you have to log it. So you automatically can't compete economically on the price of the audit. But you absolutely can compete on the price of saving energy, right? Because in their case, they cut their electricity by 40%, they cut their gas 40%. They canceled 1/3 of their solar panels because they didn't even need them anymore. Maybe that's on the next slide. Yeah, so that red there, that was supposed to be solar panels. They didn't need it. So that saved 2 rows of vineyard from getting covered with solar panels. That brought the payback to 2 months when you consider the 50 cases a year of wine that would have been plowed under to put solar panels on it. And so the quote out of there is, don't use your renewables to waste your energy more efficiently, right? And even an ultra efficient plant like that, they were able to get another 40%, right? Next slide. Okay, so now it's your turn, right? So maybe in the chat, what's wrong with this picture? So that's a chilled water tank, and it's to chill down products. So imagine you're making like Boston pizza sauce, and you put the spaghetti sauce, it's hot, into a pouch, and you put it in this chilled water bath to cool it off, and it's being mixed there with blowers. So I don't know. Let me open the chat here. Any answers?
Not yet. We're pending answers
Okay,
of what might be going on. No product.
Exactly.
First suggestion.
Yeah, where's the beef, right? So this thing was running with no product at all in there, right? Is one definite thing, right? So another one, I don't know if anybody else got one. Maybe you can click one there, Jay. I think there might be some pop-ups. Okay, yeah. Depth of tanks versus depth of product going through, possibly, yeah. So another thing is they're mixing it with blowers. which does a good job of mixing it so you get good contact of this chilled water with your product. But the blowers are 40 Celsius air. So you're adding 40 Celsius air into a chilled water tank. If you have a loading dock and they got those unit heaters, those gas things, that's about 40,000 BTUs an hour often. That's the same amount of heat that was going in from the blowers into their chilled water, right? So can we mix this? Again, you're coming back to the root cause. So if we just want mixing, can we mix it with, flow eductors or some other way rather than adding all that heat? Plus, all that blower air, when it leaves that chilled water, it's now saturated with water. It then goes up to the condensers in the room, the evaporators, and comes out as condensate, goes down the drain. So those evaporators are, another 30,000 BTUs an hour on your refrigeration system to take that moisture back out of the air that you're adding by putting these blowers on. So it's just kind of an example of kind of taking a step back. And the challenge is, there's been so much cutbacks in factories that nobody has a chance to take a step back and say, why are we doing this, right? Maybe the next slide. Yeah, so this is the same factory. So it's a bit small there, but on the right, so this is a LCD in their gowning area. So every single person in the factory walks by here 6 times a day, but it's now wallpaper. If you actually take the time to look at it, I don't know if you click it once, it might put a circle there. Yeah. Oh, thanks for blowing that up. So if you actually take the time to look at this thing that's on the wall, the water going to their cooling tower is 9.8 Celsius. After it's cooled down, it's 10 Celsius. Did anybody see anything wrong with that? Right? It's not a cooling tower, it's a warming tower. So when we looked into it, they happened to be making what's called tzatziki sauce at that time, which is already cold and going through that thing. And so technically what they were doing is just taking heat from Edmonton and putting it into their chilled water system with their cooling tower. So again, it's not very sexy, but let's just shut this thing off when you're doing tzatziki sauce. Shut off the blower, the chiller, that kind of thing. So just kind of this objective kind of root cause kind of thing to take a fresh set of eyes at your own process. And your newest employee can do it. They're just too scared to say anything about it. Why do we do this? There must be a good reason why we do this, right? But sometimes there isn't. Next slide. Dave mentioned bakery. So here's a bakery we did out in Calgary. And just put a temperature probe on it, right? And it's a good thing to do at least once, because in that case, they come in, they turn on the ovens, and then it took an hour to warm up, and then another hour before they put any bread in there, right? Or more than an hour, right? So, hey, why don't we just wait an hour to turn it on, right? And that kind of thing. So this kind of analysis is really good to do to, when should we do stuff, when, that kind of stuff. Next slide. Here's an example. So Campbell Soup in Toronto. We first did a process integration study. And so that's this detailed thermal study where you're everything in the whole factory that has to be cooled down goes on one line, and everything that has to be warmed up goes on another. It's called a pinch analysis, and these are kind of parallel lines on a slope. And there's a pinch point where at each factory is different, but a certain temperature, you shouldn't try to heat something colder than that with something warmer, because there's probably a better opportunity available. And you do this matchmaking game. And as I mentioned in food and beverage, you have more sources of heat than places to put it. But so when you quantify everywhere you can put heat, which we call sinks, and all the potential sources, then you know the quality, the quantity, the location, whatnot, and you do this matchmaking. So at Campbell's in Toronto, that matchmaking found 1.6 million opportunity with 2-year payback, which would include 3 million kilowatt hours of electricity, 5 million cubic meters of gas, that much water, that kind of thing. Then we went back and we did a food loss prevention study there. And we found, the food loss was, they're making energy out of it. They're sending it to a waste energy plant, which is fine. But there's 1,000 tons they didn't have to waste in the first place. It can be in a can being sold. If you did that, you'd save $706,000 a year. Plus, you'd avoid 4,000 tons of emissions, because the supply chain to make that ingredients is much bigger than what you're getting back in the waste energy plant, right? And that kind of thing. Oh, I see a question come up. Sorry. You see any heat at temperature that could be used for organic Rankine cycle? Yeah, possibly. It depends on each facility kind of thing, and maybe that's a good one. We'll come back to that in the Q&A. Yeah, thanks. Next slide. Jackson Triggs in BC. So they were using 85% of the town's capacity, and the town of Oliver said, you need to build a treatment plant, which we could do. But before we built it, we were able to cut the amount of water, the wastewater, in half. We were able to cut the amount of wine being lost to the sewer by 2/3, and we built it half as big, which saved them $1.5 million on the capital cost. Also saved them $150,000 on the design fee, right? And this is why people oversize stuff, is because it's the same amount of work to build a smaller one. You just make less money building a smaller one, right? But everybody else benefits if you build a smaller one, right? Plus, by making energy, so basically that's an anaerobic. We're making biogas, and then we're burning that in a boiler to heat water with that kind of thing. But we're not sending it to the treatment plant downstream, which was using electricity for their blowers. So we saved all kinds of electricity for Oliver, and we got a rebate from the utility company for that. We got something from the gas one because we're making biogas using that kind of stuff. Plus we solved their wastewater thing, but plus they sell the wine that used to go down the sewer. Not by collecting it in the sewer, but by preventing it from hitting the sewer in the first place, that kind of thing. And so it's interesting, just to think about, product also is tied to electricity and water and gas. So next slide. So on the topic of water, so say like York region has a water conservation program. So we've been a provider for York, Peel, Guelph, and Waterloo, and Toronto. And so in the case of York, 60 factories found an average of 1/3 of the water can be avoided in the first place with a 1.5 year payback. But in many cases it's chilled water, which is kind of electricity savings also, or it's hot water, or you're pumping it, that kind of stuff. So when you save the water, you save that. Plus at your treatment plant, the cost of your treatment plant is dependent on the quantity you have to treat. So if you can treat less, then you need less energy to run your treatment plant. That kind of thing. Next slide. Here's just one example. So in the York program, one of them was Arla Dairy. And so it's cheaper for York to pay Arla to use less water than for York to get more water supply themselves. So they ended up giving a check to them. So they not only save the water, they got a check towards the capital kind of thing. So that's just kind of an example, and the embedded energy of that chilled water in that case. A lot, not all of it was chilled, but a bunch of it was. Yeah, next slide. Food loss in general. So we had a grant under a Walmart Foundation. We went to 50 food and beverage across Canada. We found an average of 230,000 per factory per year of food that did not have to be wasted. If you put a grocery bag beside the CN Tower, another one beside it, you'd actually get to London before you ran out of grocery bags every year, just from 50 factories. But it's pretty small there on that. But you can see there's electricity number there. Yeah, there you go. Yeah. So in addition to the food, you'd also avoid 58 megawatts of electricity per year, and you'd also avoid that much tons of greenhouse gas emissions and save money. So rather than paying for a carbon credit, you actually would save $350 for every ton of carbon avoided at those facilities kind of thing. And so maybe the next slide.
Actually, we have a question about who initiated the incentive between Arla and the city.
Mm-hmm. So we had a contract at that time to go to these 60 factories for York region. And so they kind of co-funded the water conservation studies where we would do the watering and the associated energy savings. And then, so we identified it, quantified it, measured the flow before, and then after they implement it, you put your meter back on, you prove the water savings, and then they have a capacity buyback program where they pay a certain cents per liter per day saved towards the capital.
Okay. And so it was a program that they had established.
That's right.
Around
yeah,
that.
That's right. So there's established programs now in York, and each one has different ways they go about it, but York, Peel, Toronto, Guelph, and Waterloo have programs. No other areas in Ontario have programs that we're aware of. Bimbo Canada, so we've done 18 factories for them across Canada. So every factory they have, and we found collectively that much food can be avoided, but also that much energy. And so they were great studies because they did product, water, electricity, gas, all at the same time at each of their bakeries. And so collectively they found that, and then they got, the co-benefit, like that CEC put out that case study. So this is North America, Mexico, and Canadian governments putting out case study on them, right? You can't buy that kind of advertising, right? And so in this case, you're thinking about what else it does. So it's saving that many meals, saving that much money, saving that many hectares of agriculture to grow the grain to make that bread, saving that much carbon emissions, saving that much water to grow it, and that kind of stuff, right? And so that's kind of an illustration of that. So next slide. Just this morning, actually, the Consumer Goods Forum just put out this report here, and I think maybe Jay can put out a link to it. So that came out this morning on food waste. And so page 16 has the example of Bose Brewery out in near Ottawa. And so it's interesting, we were there as actually part of that CEC North American group for a plant tour. And we're sitting around and they have their metrics on the wall. And we looked at the metrics, we said, this is great. They were doing a lot of really good stuff, right? At Bose Brewery, they're already B Corp certified. They're already doing lots of stuff. But when you look at the wall, when I looked at the amount of COD or BOD, the amount of organic material in their wastewater, it was the equivalent to 10% of all the beer they're making. It would take, it's not all beer, but it would take 10% of your total production to make that much organics in your sewer. And they were in the process of working on expanding and increasing the capacity of their wastewater treatment system, right? Which would require even more electricity and whatnot to run. But instead, they were shocked, had us in under that Walmart one that I mentioned before, and we found 7.4% more beer yield with the same amount of ingredients, electricity, water, grain, hops, tanks, right? Now, if you can produce more 7.4% more product with no more inputs, you just doubled your profit, right? And so, and plus save the electricity and all that kind of stuff, right? So that's in that report. But basically, this report in general is like food loss is a very, very, big topic. Like 1/3 of all the food on the planet is wasted right now, which is 3 times more than it would take to feed everybody on the planet who is undernourished. Because only 1/9 of people are undernourished. And it's where all the margin is. And, people don't really understand it. If it ends up in a dumpster and you get 50 cents on the dollar, you just made 5 times more on that stuff than you did on your grade A #1 stuff that you're only making 10 cents on the dollar. And so it's a whole rationale, but it's the embedded resources that are being lost in that food. So next slide, maybe.
Yeah, and that actually brings us to the Q&A. So I think Bruce, I think that was a really great presentation and a lot of great examples of these opportunities, energy saving opportunities that come through that holistic approach. So if anyone does have questions, please add them to the Q&A panel accessible at the top of the Teams, in the Teams toolbar, and we'll get to them. So we do have a healthy amount of time before we wrap up on this. Maybe we'll start off with David's question from earlier on about, do you see those heat at temperatures that could be useful for organic Rankine cycles for making electricity?
Yep. So that's a great question. And basically what we would do is when we do our study, we would come up with a source and sink balance. So everything that's a potential source of energy, of heat, and everything that can use it. And when you do that, very often there's good matches within the process. So yes, you could make electricity, but you're just going to use that to do something else anyway. Let's do that directly. Use that heat directly over here for that kind of thing. Is one consideration. The other consideration is the quality of heat, right? So to get a Rankine cycle going, you need fairly good quality of heat. And so you may or may not have that at your facility because you've been more efficient. So you didn't waste that quality of heat in the first place. But yeah, it's worth considering. And particularly now, once you get into the deeper retrofits of trying to get to zero, right? So you're going to, traditionally our payback has been 1 year. But now that we're helping get people to zero, it's extending out now to 2 years, 5 years, these kinds of things, because you have to go deeper and deeper to get the deeper retrofits. And so when you're thinking about that, so say like even yesterday, I was just speaking with somebody who's developing a supercritical CO2 heat pump kind of thing or whatnot. So you have to get into this more advanced stuff to try and get the deeper retrofits. Yeah. So we haven't put in an ORC cycle yet, just because we haven't found a good fit for one, but conceptually, we would be happy to consider them.
Right. I was wondering if, so at the beginning we saw, people who had done those low-hanging fruits, but then are kind of transitioning into like these more complicated systems, starting to ask those right questions. And I think the approach you outlined in terms of taking that systems approach is really helpful in those instances. I wonder if you have any tips for people who are starting to go into that, like either in terms of engagement or changing the mindset, or what are those things to help them move in and take that holistic approach, that systems approach that you were talking about?
Yeah. I would say a good example might be that Campbell soup one I showed. So when we went into Campbell's, they literally had 200 ideas in their suggestion box, which is basically paralyzing, right? And so instead, we did our study, said, yeah, there's 200 things you could do. These dozen will save you 1.6 million. So basically, it's a prioritization. And it gets you around, everybody's got their pet peeves. Oh, it's lighting or it's recycling, it's whatever there is versus, what are your biggest ones, right? And what can you do on those biggest ones? So that kind of prioritization stage is very key. So you're working on the right part of the problem. Say like we've done the space shuttle down in Cape Canaveral, and Pratt & Whitney always looks at their 3 largest waste streams. And once they're done, 3 other ones. So we did their 3 largest ones. Now 3 other ones become the 3 largest waste streams. That was a while back, when they're doing the space shuttle, when we did water recycling. But just that philosophy of continuous improvement, but starting with the biggest problems and kind of the root cause kind of thing would be very key, I guess.
On that note, we have a question from Max about how long does that typical site assessment, where you take that holistic view of it and the root cause analysis from your examples, like how long is that process typically?
Yeah, no, it's a great question. So typically 3 to 4 months. However, the field work itself is typically a week. So basically, the way it might look is, show up, do the kickoff, do the site walk, where you're picking where you're going to put all these meters, right? So we're going to supplement whatever metering they have with our own temporary metering or permanent metering if they prefer that. And we log for a minimum of 1 week. What's happening at Sunday morning at 1 a.m.? These kinds of questions, right? Does the water ever go to zero? These kinds of things, right? Comes out of the metering. Then we meter that, and over the course of the week, that's where we're observing a sanitation shift. We're watching, we're talking to people while they're doing their jobs. How are you going to do this CIP, right? Okay, at this point, we want a sample right there, And so we were collecting our data so that we can, when we make a recommendation, it's quantified. It will save you this much. Not, theoretically at other places it is. It's no, at your facility, this is what it would be, right? And so that requires that level of detail. So we do that for the week. Then, we go away for a few weeks where we're analyzing the data and all that kind of stuff, coming back with the things we're recommending, right? So then we have that progress meeting, and that's the key part of the whole progress. So you still got your stakeholders, and we say, what about this? Well, we tried that 10 years ago. Okay, well, was this available 10 years ago? No. Well, how about if we tried it like that? Or what was the issue last time? Can we, if we can get agreement, then we keep the idea. If we can't, we throw out the idea. And then we take that idea, do the installed capital cost, get a budget quote, right? Now it's enough. That idea has been around for 20 years, but nobody knows the business case for it, right? Because nobody's measured it. So it's not in a position where anybody can actually implement it. Once you've got it, then you can apply to various ISO or wherever else to get co-funding. But if you don't know the business case, you can't apply to any of these programs either. So it's in a format you can do something with. And then lately what we've done is we've been selling what's called fractional engineering. So say like Gailey, we did 6 factories for them last summer. And now we work for them 1 day a week for a year. So every Friday, our engineer works for them at their facilities. What's the next one? Okay, what do you need? Whatever it needs, we're just selling the will to get it done, literally, right? Because they got 10 other problems that came up since breakfast. But ours is only to keep an eye on these opportunities until they're done, right? And just, we've got the status of all the ideas and what's the next step and, where we're working on and when we're done, can we prove it? Can we get a rebate from somewhere? So just your eye on the ball. So because really the implementation is the key step. A lot of people have a lot of reports on their shelves that save them nothing.
On the discussion on the business case, like there's a lot of talk about, the food loss or, the wastewater and that gets lost, and there's all of this energy that's embedded in the product that's going down the drain, whether it's water or food product. Do you have any tips on like how do you quantify what those energy savings or what those other upstream savings from that might be to help build that business case?
Exactly. Yeah. So we generate what's called an opportunity table at the end, and so that opportunity table has got the idea on the left, and then it's got the water savings, electricity savings, gas savings, ingredient savings, net savings, capital costs, rebates available, and return on investment, or however they make their decisions, net present value, whatever RONA. So it's all, and greenhouse gas scope 1 and 2 for your operations, scope 3 if you're saving ingredients. So you've got all that in one place, right? And then you can prioritize however you like from that. And so you quantify the co-benefits, because very often it's the co-benefits that sell a job. Without the co-benefit, it's a 5-year payback. But if you include that, now it's a 2-year payback, right? And so, and your co-benefit may include your wastewater surcharge, right? Because those ingredients, your wastewater surcharge is basically ingredients you bought that aren't in your package being sold, right? And then you're paying Toronto to destroy it, if you're in Toronto or whatever. But interestingly, say like Labatt's in London, we have a sensor on their effluent for their effluent organics, but it doesn't report in COD or BOD. It reports in cases of Budweiser beer. It's not all Budweiser beer, but if it was, it would take this many cases to make what you're seeing, right? Just to raise the priority level and to make it more relevant, I guess. Yeah.
And is that like representing the cases of the Budweiser that's going down the drain? In terms of, is the information around like, oh yeah, and the energy to produce a case of Budweiser is this,
exactly.
and the upstream cost to produce it, like, is that information typically readily available at these facilities? Or
for sophisticated like that, it would be, because they would know how much kilowatt hours per liter of beer they make, how much gas, how much water, and they have metrics on all those kind of things. So in their case, but if not, it's not very hard for you to calculate yourself. I would just take your total electricity for the year, your total production for the year, and divide them. Right. And so if you save product, you save the electricity, because you get the same amount of product with less electricity.
We have another question of, do you use the lower energy in the marketing of the product? So you talked before about, kind of in the intro, about the value to the brand and things like this.
Yeah.
And have you seen companies do that really effectively after they've been working on this?
Yeah. If you go buy some bacon at the Sobeys from Maple Leaf, you're going to see right on their net zero carbon, a labeling right on their product, kind of thing, right? Others, you can see upcycled ingredients on it. Upcycling really reduces your footprint because you get it at your door at 0 footprint because it was previously lost, right? So you can make a lower footprint for your final product by starting with an upcycled ingredient instead of a virgin one. So we're seeing some labeling kind of stuff like that. We have another customer, they're not in the food, they make they're in the manufacturing, and they make these cutting tables with this robot and a arc cuts out these metal parts. But every time they sell one, it's 5 times less energy than their competitors. So their customer uses 5 times less energy to run it. So their customer's footprint. So they use that in their marketing, that kind of stuff. But I would really encourage you to look at your handprint kind of stuff too, that scope 4, which is kind of, let's say you sell a say Maple Leaf is getting into plant-based protein also, right? It's less footprint to make the same amount of product, that kind of stuff. And so you can market that kind of stuff also. So yeah, the key to that is to quantify it and make it credible and material to what you're doing.
Another thing that you mentioned, that sometimes these opportunities come up and it's like, oh yeah, we looked at that 20 years ago. And it's like, well, things have changed since then. I was wondering if there are any new trends or technologies that you've seen in the last couple of years that are particularly promising in the food and beverage area, or things that people who have been doing this for a while may not be immediately aware of that's coming onto the scene.
Yeah, so I would say we always start with the simplest solution first and then proceed to the more complex. And so your question brought to mind a cheese factory we did. And they had an idea that was 5-year payback to take their refrigerant, add another compressor to make it even better quality heat, and then use that heat to heat their wastewater. However, they only needed low quality heat to heat the wastewater anyway. So you can avoid that whole extra step and bring the payback from five years to under 1 year. So always look at the complexity of what you're doing and can we simplify that and the job. But as far as technologies, like I mentioned before, we're installing a heat pump next week at our own office. In Ontario, you have the very strong advantage that it's only 10% fossil fuel in our electricity. So say like if you have a plant in Toronto and another one in Chicago, it's 10 times cleaner to start right off the bat on your electricity footprint, right? So it's much easier for an Ontario company to get to zero carbon than somebody in another one, because you only have to replace that 10% instead of 100%. So basically it's, relatively easier to kind of reduce as much as possible, then electrify and then replace the rest. So in our case, we're going to electrify our remaining heat with a cold temperature heat pump. That's going to provide eliminate almost all of our natural gas. It'll go down to -30. And then we've got less electricity, which is a much smaller footprint issue. So that's pretty strong, I guess. There's a lot there. It's just it's most of the time you're not inventing something new. You're just making better use of what's available, and cross-fertilization across, hey, this in aerospace would work in food also, or that kind of thing. And so say like a Unilever, they're starting to develop these very esoteric ones, right? But that's for that last mile. How are you going to get there? But the first mile, cutting your footprint in half, that technology is already available.
We do have a question about in your analysis and assessments of here, if you use the RetScreen software at all, and like how applicable that might be, if you have experience, how applicable that might be to food and beverage versus like commercial buildings.
It would work for sure, and it's got modules in there also, and it's good for RetScreen's originally maybe for doing buildings, but you can also get process stuff in there also, and so it's a good way to keep track. And say one of our Toyota customers, one of their supply chain uses that quite effectively to monitor all the stuff he's doing and getting his sensors even to feed into it, for performance. And so yeah, it's a good program. It's relatively low cost.
One of the things I was wondering is that we heard a lot of examples that you shared that kind of fall into, well, it's the way we've always done it. It's like we're doing it this way. It's the way we've always done it. I was wondering if you had any advice on how to help organizations overcome that inertia and sort of like break down the barriers of like, maybe we can do it another way. And then also, after the fact to help maintain it and not revert back to the way we've always done it.
No, that's a great question. And the key to that is actually to bring everybody on board. So that stakeholder group, what you want to do is get that group together and put the problem over on the side. So everybody's looking at that. Yes, it's a problem in the boiler room, but it's not the boiler operator's problem. You know what I mean? So that people don't take it personally, right? And you've got the various silos there. And so a good example would be a sausage factory we did. And they were losing, another thing is nobody ever measures anything, so they don't know what it cost them. But in their case, they were losing over $300,000 a year of sausage from their metal detector. Now, 0 of that actually had metal in it. Every day, they would put a ball bearing in, and it would spit that ball bearing out with a bit of sausage. That's great. Just keep doing that. 12 times a day, they would put a wand under the sensor that never touched the product that would spit out the same amount of sausage. That added up to 350, right? And so from a QA silo, yes, that's perfectly fine. That's great. There's no risk. In my world, no change is no risk, right? But if you have somebody else in the room also, right, operations or whatnot, can we solve the same thing without wasting that much food that somebody could eat, right? And still have the same, and there's maybe 10 different ways to solve that, right? And with that group, you collectively work on that, right? Because you're actually protecting every job in that factory. Can we afford to waste $300,000 a year of profit? Because our competitor isn't some other meat company. It's our own company somewhere else. And the more efficiency we can embed in our operation at this location, the safer we all are, right? And so you have to get people to move beyond the silos that they're looking at, right? So that say a maintenance person, hey, this is more work for me to maintain this thing also, right? But I'm protecting 1,000 other jobs in my factory, or 500 or 50, right? And so you have to get them to that point of this is why we're doing it, right? And then on the metering side, so very often you can put a permanent meter that will warn you, say your air compressor, our leaks are now 37%, right? Here's a text message, or this trap seal water, the solenoid broke and it's sending fresh water to the sewer all day long every day, right? Boom, here's a warning. So what you have to do is you have to get to that really specific process level with those warnings, right?
All right, great. I think we're getting close to the end. We've got a couple of things to wrap up. If anyone does have any other questions, you can still put them in. We might be able to squeeze them in right at the very end. I really want to thank Bruce for taking the time to join us today, and everyone on the call as well. One thing I do want to highlight is the Save on Energy program does have free advisory services available on energy management, on industrial energy efficiency projects. So if there's anything coming out of today, you have access through Save on Energy. I think this is a really great opportunity through the program. You can access this either by signing up for Energy Manager Support Services, and the link just got dropped into the chat. It's free to sign up. You get access to the Energy Management Learning Platform that has online courses for free available, a discussion forum where you can post your questions, and we will have subject matter experts respond to that. Or it also gets posted there for peers, or for you to answer for peers, or to hear from others in the industry. It's a really excellent resource. If you have any questions specifically for Bruce coming out of today that you may want some advice on, that can be covered. Bruce has kindly offered to provide some brief follow-up advisory support to anyone who's interested. You can access that either, as I mentioned, through Energy Manager Support Services and posting questions on the forum, or you can email training-and-support@ieso.ca. So I think it could be related to stuff we talked about today, but even anything else, we have the ability to access a network of subject matter experts to help you out, to provide that advice and support. So please take advantage of that offering. One last thing, there is page 6 of that worksheet, participant workbook that we have for you to note down. And I encourage everyone to note down some actions that came out of today that you're looking to implement, just for your own purposes, for your own reminders. What do you want to act on that you heard about today? And our last Menti activity, if you could go back to menti.com, the information's at the top. And I'd love to hear, what will you do in the next week to start capturing some of these energy saving opportunities? So if you still have that Menti window open, just go back to there, or the link is in the chat. We'll just drop that as well. But before we leave for today, I would really love to hear what's something that you're coming away with from today's session that you're going to act on in the next week. Now, it might not be, solving your whole root cause issues on here and changing your processes, but what's that first step that you're looking forward to taking within the next week? We've got a few minutes left. If there are any other questions for Bruce, we're happy to answer those in the last few minutes are left. But before you go, please do answer the question in Menti. Bruce, is there anything else that that we haven't had a chance today that you'd like to leave the participants with in terms of them moving forward and taking these next steps, or getting started down this approach?
Yeah, I guess just one thing that comes to mind, there's a professor at Harvard, I've forgotten his name right now, but anyway, his quote is something like, the benefit of these environmental things might not even be the environmental things. It's the benefit is in teaching teams how to work together. So when we do our work, environment isn't the top of everybody's list, but it's on their list somewhere. So when you get those stakeholders together in the room, you've got a common project for them to work on that's on their list somewhere, right? And then when you see the initial success of that and the effect it has, say like that sausage, like $300,000 a year, if that goes right on the bottom line, how much sausage do you actually have to make and sell every year to make that much profit? So it's the best investment you can actually make is in your own facility. But once they get that experience of working together, breaking down the silos, then they can work together on other things also, right? Because you're building those relationships. And they're not just thinking about quality anymore. They're thinking about quality and this, right? Not just thinking about the refrigeration, keeping the thing going. It's this and reusing the heat or whatever else. So you get this cross-functional knowledge, I think is kind of a key underlooked thing of just kind of teaching the organization how to learn. The question here, do you see the renewables going back on the roofs? Yeah, so interesting. The very first question we often get is, should I put solar panels on the roof? And my answer is maybe. If you do, you're up, a decade, that kind of order of magnitude to get your money back. Is there something better in the plant to be done first? And invariably, there's something with a 1-year payback that can be done to not use that energy in the first place. Now, it's not as sexy for your marketing as a solar panel, right? But it's much better for your bottom line, right? And so it's a good thing to consider, but it's not the first thing to consider. And then, as I mentioned in our own case, we don't put them on our own roof. We got water on our roof, and our roof is in Elmira. So we put them on the roof in South Sudan. We get twice as much electricity because there's twice as much daylight. We shut off their generator at the orphanage. So we're 10% fossil fuel, they're 100% fossil fuel. We get 20 times more environmental benefit from every panel. Then they can use that diesel money for food for the kids at the orphanage. Now we get a social benefit. So that's kind of why we don't do it on ours. But solar panels is worth considering, but it's not the first thing to consider.
All right. So again, thanks everyone for taking the time out and joining us today. Hopefully there were some interesting tips. We've got some nice things that people are pursuing in the next week, discussing food loss, update training plans, ID sinks and heat sinks and sources, looking at some root cause analysis, and checking in with site teams on this. So that's really great. Good luck with all of those actions, applying this at your facilities. And I do recommend reaching out and taking advantage of that advisory support that is available. So thank you everyone for joining us today. As mentioned in the chat earlier, a recording of this will be posted on the IESO's training website. There's lots of other good material there, and it will also be sent out to participants. So have a great rest of the week, everyone, and we'll see you at the next workshop.
Thanks, Jane.